Whatever. Once again, Terry here in D-Lab with...
Two-Bit Girl.
He got it right that time. That's good. Now what we're going to be doing in some little mini-series with Emmy is to show her the basics of tube amplifier repair. You got to start somewhere, right? So what we're going to do in this video is we have a Fender 5F2 kit behind us here that was sent in to the shop, and it's dead. So this is the perfect video for Emmy to get her feet wet, right buddy?
It's just an expression.
Whatever. Alright. So here it is. I'll give you a quick overview. The little 5F1 chassis, power transformer. This is the output transformer. It only has a volume knob, fuse holders up front, just like you'd see on the vintage amp. Built point to point on an eyelet board. Right? And this jobber is dead at this point, from what I hear. But we are not going to power it up until we give it an inspection. So I mean, this was this person's first kit build that he has attempted, okay? And he built the thing, and unfortunately it didn't work. I tried to talk him through some things on the phone, but it didn't go so well. So I just said, ship it here, right? So here it is. There's the amp. So you can see the construction. You got some resistors here, some capacitors. These are the power supply caps right here, okay? Power transformer over here, and then you got sockets for the tubes. Now he didn't send any tubes, which is fine, because for our part in this we really don't need them. This is a simple inspection, right?
Grandpa, what's holding this board in here?
Well, that is a good question, Emmy, so let me get in here and take a look. Alright, so you can see right here there's a big hole, and behind that is another hole in the chassis, and I believe there's supposed to be like a mounting stud in there. Also, when they use these eyelet boards like this, since it sits so close to the chassis, there's usually another board behind it to insulate it, and I don't see that. So guess what could happen if that board were to hit the chassis?
Oh, yikes.
Would maybe get some sparking, right? So it's an unsafe condition. So we do need to remount this board, right? Let's take another look. Now, like I told you before, the amp is dead, right? So if it's dead, the first thing we need to do is check the power transformer, see if it's alive, right?
Alright.
So we're going to start with the power transformer, okay? Now, as we talked about in the past, remember I explained how transformers are wound? It's nothing more than wire, right? And you can see it in this transformer. See all that wire? There's a big spool of wire in here. So they have what's called a primary and a secondary. Okay? That's what this transformer down here has. So if I were to take my meter, an ohm meter, remember we talked about ohm meters, right? So there it is, that's open and that's closed, right? So if we were to look at the AC cord coming in, the power switch is on, right? So if I take my meter and go across here, you see on the meter, see that? Now turn the switch off. Okay, see it opened? Oh, turn it back on. It's closed. So now you know that the primary of that power transformer will see the power coming in, right? So the primary and that fuse is good. That's a good sign. Now, let's take a look at the secondaries. So you're gonna have to move your arm. So this is what they call the rectifier tube socket, okay? That probably doesn't mean much, but this is just on the other side of the power transformer. You check the primary and it was good, right? Now we're going to take a look. Kind of hard for me to get in here, but across these two yellow wires there's a winding, and that's the 5-volt winding that turns on the rectifier tube, and that's there. See it? See the open, close? So that's there. Then we got the two red wires, right? That's the high voltage windings. Okay, so I'm going to take this, scale it up a little bit. Same deal, check your leads.
I do see a couple things though.
Okay, well let me buzz this out first and then you can tell me what you're seeing, okay? So we got the red wire here and the other one's back here. See on the meter? Alright, so we have resistance across the two red wires, and that's a good thing, right? Now, if we were to scale it down Let me look at that again. You got what? 256?
256.
Okay. Now they have this yellow stripe on this wire, and that is the center tap. Okay. So between the two reds is this red wire with yellow stripe, and that's supposed to go to the chassis of the amp. Okay. That's just how it works.
So it should be probably like about here in the middle.
Yeah, but what should that center tap measure? If you got 255, you said, across these two, and this is in the center of that, what would you get to that center tap for a number?
I'd say around 120.
Okay, good. So I'm going to let you do this. There's no chance of getting shocked. This thing has not been turned on. So take this red and go to one of those red wires. Okay. And then take the black and go up to the one with the stripe.
Okay.
See what you get. All right, so you have one on the red and go to the red yellow. Let's see what you get for resistance. All right, 122. That's about what you expected, right? Yeah.
Around 120 was my guess.
Okay, so remember I also told you that the red yellow has to go to the chassis. So if you were to touch those two leads to the chassis, see how you got 0 ohms, right? Now keep one on the chassis and put the other one to the red yellow lead, just like you did before.
I'm gonna keep this one right here.
Okay. Okay. So what do you got?
Nothing.
Right, it's open. Okay. So let's get that out of there and let's take a look at why the red yellow is not connected to chassis. It's probably going to be pretty obvious, right, Mr. Obvious? Okay.
Mr. Obvious.
Yeah, so take a peek in there. Tell me what you see. Red, yellow.
I wanted to show you that one of these and there was one more that I saw right there.
Oh,
I saw those black marks.
Oh, good eye. You're right. There are some little arky sparky marks. So that could have been caused from a soldering iron, maybe, overheating the wire, or somebody could have accidentally had a probe in there. Oops, let's not knock the camera over. And, caused a arc and burnt the wire, okay? So back to the question of the red yellow wire not being connected to the chassis. What do you see in there that can cause that?
Maybe because this isn't in the middle, and the middle is actually the one that's connected.
To ground?
Yes, to ground.
Okay, let's get right in here so everybody can see it. You are correct. So you got a green wire here going to the ground. That sounds good. And then you got the red yellow that's going to a terminal that's just floating. So you know what that would do? That would make the high voltage inoperational. It would not work. The high voltage would be dead because the rectifier tube relies on that wire to be connected to the chassis. So that's the first problem with the amp, right?
Right. Righto.
Righto. All right, Emmy, next thing we need to check is the grounds on the filter caps. Now, I put a lead on here so you can do your measurements now with one lead. You don't have to struggle with the two. So the negative side of these capacitors all need to connect to chassis, just like that red yellow wire, okay? So start over here, hit that one. Tell me if it's okay.
It looks good to me.
Okay, now go to the one to the left of it.
Oh,
Oops.
I don't
Yep, try that next one. There's a third one in there.
see it. Nope.
Okay, same deal. Okay, we have an open. Now, if you take a close look, there's a wire right up there. See that green wire?
I see it.
Where's it going?
Going straight right there. Right, exactly.
Yep. So guess what? You got the same problem. It should have went to that middle terminal of that terminal board, right?
Again.
So there it is. So we've determined that part of the power supply isn't connected properly, right? And the output of the power transformer is also not connected properly, and that's why this amp won't power up. So it should be a simple matter of hooking those wires up where they belong, right? and then we can carefully bring this amp up and see if it powers. Cool? All right. All right, Emmy, so we've determined that the power supply needs to be rewired. Now we're going to look at the output transformer, okay? So the output transformer feeds this. This is a speaker jack, all right? So keeping your ground where it's connected, if you go to that middle terminal, you should see a low resistance because that's going to the speaker.
Nothing.
Open again, huh? Okay, so now pull your hand out of there so people can see. This wire right here goes to the output transformer. This is the secondary. That's what feeds the speaker. And you saw another burnt mark, right? All right, so if you were to take a look, that lead needs to go to this terminal. What do you see?
The wires, they're switched.
So this wire is not going here. This wire is actually going right to the chassis, right? Because they're flipped, right? So the funny thing is you only see one wire coming up from that transformer. You would think there'd be two, right? There's only one. So let's see why that is.
All right, Grandpa, well, here's the lead going to the jack.
Yep.
But this one's only soldered on.
Okay.
Why is that?
Well, a lot of times what they'll do is they'll solder one other half of that to the case, and then when the case is screwed to the chassis, it'll make connection, okay? It's an okay way to do it, but if this transformer were to become loose, say these screws loosened up, guess what your speaker would do? It would cut in and out because you could lose that half. So really the best practice is to have a wire from here actually soldered to that output jack. That way you'd always have a good connection, right? So I guess we'll do that too. All right, Emmy, so there's several things wrong with the build, right? I mean, there's a lot of things that need to be cleaned up. Things need to be rewired. What do you think? What do you think I should do?
I think you should gut it out and rebuild it.
I think you're right. It's going to be a heck of a job, really, because you've pretty much got to tear all this out, and hopefully I can bring this board out, lay it out where I can see what's going on. Yep, it's going to be a job, but I'm up to the task, because what does B-Lab do? Huh?
I'm guessing around 5 to 6 hours.
Yep.
Or more.
But who's the guy for doing that? Who's the man? What? Not cool. All right, Amy, so here's my plan of attack. We know it needs to be completely rebuilt, right? We agree on that. But what I'd like to see first is, can it even come to life, right? So I'm going to fix those obvious things that you pointed out, right? And I'm going to bring this thing up slowly on my Variac, and I'm going to see if the amp will operate, right? And then once I know everything's cool, then I'll gut it out and do the complete rebuild. What do you think? Good plan? All right, Emmy, so I've temporarily repaired all those problems that we saw, okay? So that's why all the wires are hanging out of here, and now we got tubes installed, right? So remember all those missing grounds that we had? Now they are connected. So we should be able to bring this thing up on my Variac very slowly and see if the amp powers. All right, Em, so what I'm going to do, we know that the amp appears to be wired right. I've got a meter now set up, and we're going to look at the high voltage going right into the output tube, which is the 6V6. This little crazy thing is just a resistor, and it's going to simulate a speaker. So I'm going to bring up my Variac nice and slow over here, and you should start seeing this meter going up if things are good, okay? I'm over here watching my Variac, and I'm watching the current. If I see something go wrong, look at, what do you see? Look on the meter, Emmy. Do you see?
It's moving.
Yeah, that's 125 volts. Yeah, so this is the point where it gets dangerous, okay? if you get in here and you're fooling around, this will go up. As I turn the variac up, watch the voltage. See how it's going up, up, up? Okay, so I'm gonna turn it down. We're gonna let things discharge, but I bet you that this amp will give us some kind of sound at this point. Let's get a speaker hooked up, okay?
Okay.
All right, Emmy, so I am bringing up the variac now. Now we have a speaker hooked up, right? So hopefully you'll be able to hear something. So once again, I'm watching the current, I'm watching the voltage. I'm up around 80 volts input. So there's probably a good 350 volts right there. So you do not put your fingers in there, right? It'd be very bad. All right, so let's keep it quiet. Let's see if we hear anything out of the amp. A little bit of a buzz. Okay, I'm at 90 volts in. I'm gonna try the volume. So it's working. Okay. It's probably not working properly, but it is producing sound. It's a lot further ahead. Now the next step would be gut it, right? Yeah. So anyway, I'm gonna buzz out some other voltages and see what else is going on, but I think there's some promise for this amp. High five. Thanks. You want to be in here or not? You're not in there.
I'm sitting up straight.
That's good. No, I'm just bringing it over. There we go. All right, Emmy. You know, it was working, but the preamp gain appears very low. So what I'm going to do is we're checking the voltages going to the 12AX7 tube. Okay. So on one side here, we should see about 180 volts. Okay. Now I'm not going to bring it up. Don't get near this thing, please. Look. So we got like 200 volts going to one side of the 12AX7. I'm going to turn all the way down. Now, let's hook up over here. This is the other half going to the 12AX7. Okay. Let's bring the voltage up again. Take a look. What do you see?
It's only at 11.
Yeah, it's not good. So there's something either miswired or we have an open resistor, which is another reason I need to tear the thing down and rebuild it. Right? Right.
Righto.
Righto. So that wraps up your first tube amp repair 101 at D-Lab Electronics. Huh? So what have you learned from this, buddy?
That you should always give a good inspection before you power it up.
Yeah, because if we had powered this thing up in the condition it was in, there may have been some fireworks, huh?
Yeah, no kidding.
Yeah, no doubt. And you really don't want that to happen.
What? It'd be like, I came in like a wrecking ball.
Plan on the Champ here is to totally gut it out and rebuild it, okay? So here's that eyelet board, and you can see there's no insulator on the back. So I'm gonna have to build an insulator, and I'm also gonna add standoffs to mount this board securely. So what I elected to do for an insulator is I used an old piece of circuit board material. So the copper's facing down, the fiberglass is up. I've got some 1/4-inch aluminum spacers now that the board will sit on, and I'll put some nuts on there to mount it. Should be nice and secure and safe. Project's moving along well. The thing I noticed that I wanted to point out is this 470 ohm resistor here. That's the cathode bias resistor for the 6V6. And it looks like it's only maybe a 1 watt resistor. That's way too light. So for example, let's say we had 50 milliamps just for fun, okay? So we'd say 0.05 times 0.05 times the 470 ohm resistor. That'd be a little over a watt of dissipation. So this guy would run hotter than a firecracker. So I'm going to take that out and put it in a 5 watt. Well, here we go, initial test after the rebuild of the little 5F1 Champ circuit. Got an oscilloscope monitoring across a dummy load resistor, simulating a speaker. We've got the audio generator up here. We'll kill the shop lights so you can see the scope. Ooh, that's pretty dark. Get a little more light on the situation. How's that? So here we go. Bring up the volume. You can see our sine wave over there. Vary the frequency here on the generator. Excellent. I'm going to crank her up and see what kind of distortion we get out of this Class A circuit. Look at that. She's really working. And it's nice and quiet. There's volume all the way down. Oops. Bring our amplitude down so we can look at our noise floor. This is one good working champ now. So a successful repair of the Little Champ 5F1 circuit. Now I want to share with you guys, the person that sent this to me really felt bad that he bought this kit and then didn't do such a great job building it. He felt like he kind of failed at this effort. Well, here's the deal, guys. We all fail when we initially try something, okay? I've been doing this stuff for over 30 years. You think that I didn't hit some bumps in the road? You think that I didn't smoke some stuff? Sure I did. But I kept trying. And that's what I admire about you guys that are building these new kits. Even though you really don't have a clue yet of what it's all about, at least you're trying, all right? It's better than being on that phone and saying, man, I'm an expert because I see it on my phone. You're actually putting forth the effort to do it. I'm proud of you. Keep it going, guys. Someday you can be as old as crusty as me, putting on videos. We'll see you.